Hello, this is Mr. Wynn, and this video is about operations with polynomials, and it's very important in Algebra 2. When I talk about operations with polynomials, I mean adding, subtracting, and multiplying. And before we do that, some vocabulary we need to know. A monomial is one term. It's a single number, variable, or expression that is the product of one or more variables with non-negative integer exponents. So exponents can never be negative. We have to fix that. I'll talk about exponents in a second. Some examples are just the plain old 5 by itself, nothing combined, or plain old x by itself, or plain old 6y by itself, or 2 times a to the 5th times b to the 7th. Right, those are all single terms. There's nothing to add or subtract or combine with it. Polynomials are many terms. It's an expression of two or more terms that can't be combined. So some examples is x plus 5. Those don't combine. It's two different terms. Or we have 3x squared minus x plus 3. Those are three terms. They're called a trinomial, but they can't combine. Or even this one here, a times b squared plus a squared b. Those are different. They don't combine. All right, so there's plus or minus. It's a polynomial. It's no plus or minus. It's a monomial. We also have degree. Degree is the highest exponent for a variable, and it can be negative. If there's multiple terms, you pick only the highest. And so let's just talk about this real fast. For the top part, degree goes on letter. There's no letter for this 5, so this has a degree of 0. This x has a 1 that's invisible there, so it's a degree 1. The 6 doesn't have anything, but the y has an invisible 1, so that's a degree 1. If there's multiple letters in a term, so there's lots of letters in this one term, I have to add up the exponents of those letters. So 5 plus 7, that's 12. This is degree 12. Right here, this is multiple terms. Oh, I'm just going to go down here. 33 has degree 0 because there's no letter. 2x plus 5 has degree 1 because this has a 1, the 5 is a 0. Between 1 and 0, 1's higher. This one, 3x squared, has degree 2. 100x is degree 1. 25 is degree 0. The highest is 2. Again, right here, this is one term, but I have to add up the exponents because there's multiple letters. So 5 plus 2 is 7. Then down here, we have 45, 3, and 2. That adds up to 50. B only has 47. The bigger number is 50. So degree is the highest exponent for a term. All right. Also, if we do polynomials, we have to remember all our exponent rules. This has all of them. They have really good examples, so please look through those. I'll go over a couple. One thing I need to say is if you have a number with an exponent in your final answer, make sure you fix it. For example, they have 3 to the 6 here. We should change 3 to the 6 into 729. And here they have 9 cubed. We should change that to 729. So you have 5 squared, change it to 25. All right, but there's technically 5. We have product of powers. When you multiply the same bases, the base stays the same. You just add the exponents. So right here, they have 3 squared times 3 to the 4th. It stays 3, not 9. You just add exponents. 2 plus 4 is 6. That's why they have 3 to 6. Same for letters. P squared times p to the 9 is p, and then 2 plus 9 is 11. So when you multiply same bases, you add the powers. When you divide same bases, you subtract the powers. If you have a negative exponent, you just make it a fraction and flip it to the other side. So if it's a negative on top, it goes to the bottom as a positive, and vice versa. If it's a negative on bottom, it goes to the top as a positive. Power to power, power of a product, and power of a quotient. These are all the same thing. Basically, there's one term inside of parentheses, and then everything inside of parentheses has an exponent. There's exponent outside. We call it power to power, exponent to exponent. You just distribute the outside exponent to every exponent on the inside. And I'll do a problem in a second, but they have examples on the right. The last one is 0 power. Anything to the 0 power is 1. And if you have a calculator, you can just test it out. So 5 to the 0 power is 1. All right, so here's some problems I'm going to do with all those rules. So the first one says a to the 5th times a to the 7th. Well, since they're the same base, they're both base a, it stays a. Then I'm going to add 5 plus 7 is 12. Second one, 5 to the 4th times 5 to the 9th. Base are both 5. It stays 5, so do not multiply for 25. Then 4 plus 9 is 13. This next one, m to the 5th divided by m cubed. Same base, it stays m. I'm going to subtract. 5 minus 3 is 2. 7 to the 6th divided by 7 squared. It stays base 7. 6 minus 2 is 4. And again, you're supposed to be multiplying, typing in the calculator. 7 to the 4th power is a big number. 5 to the 13th power is a big number. But for the interest of time, I'm not going to fix those. This one is power to a power. Inside is one term. There's no plus or minus. You're allowed to multiply or distribute the outside exponents to every exponent inside. So it stays x, and then 2 times 4 is 8. This is also one term. It's 3p to the fourth, 3 times p to the fourth power, no plus or minus. You're allowed to distribute every the outside exponent to every exponent inside. Be careful, a lot of cases this is wrong because the 3 has an invisible 1. There's 2 exponents inside. So I multiply this 1 times 2 and then the 4 times 2. So stays 3, the exponent will be 2 times 1 is 2. Then stays p, the exponent will be 4 times 2 is 8. And technically you're supposed to change that 3 squared to 9. So the final answer should be 9p to the 8th power. Down here, same thing. It's one term on the inside. I can distribute the outside exponent. Inside there are 5 exponents. There's an invisible 1 right here for 3, invisible 1 for the z. So this 3 will multiply all those. So it starts out 4, 2 times 3 is 6. Then x, 4 times 3 is 12. Divided by 3, 1 times 3 is 3. Y, 5 times 3 is 15. And then z, 1 times 3 is 3. That's the final answer there. Alright, here are the negative exponents. Since it's on top, it's going to go to the bottom of a fraction. So I do like this, and it'll come to the bottom like this, as a positive a to the third power. If there's nothing left on top, put a 1 there. Same for this next one. This is over 1. This whole thing will come down to the bottom, has a positive 5 squared. Now there's nothing on top, so we'll put a 1 there. On the other side, these will go to the top. So this will be x to the positive 8. You do not need to put over 1. You can. This next one, 2 squared over 8 to the negative fourth, you cannot just reduce 2 over 8 to 1/4 because there's exponents. When something has an exponent, you can't use it to reduce or simplify. But what we can do is move this to the top. So really this is 2 squared times 8 to the positive fourth. You're then supposed to change 2 squared into 4, 8 to the fourth to some big number, then multiply those. Or you cannot do 2 times 8 to get 16 to some power because they're different. Then we have the 0 power. A number to the 0 is always 1. Same for a letter to 0 is always 1. This next one is 2x together. So there's some parentheses to the power 0. If the 0 is outside parentheses, that's also 1. If you want to use the rule to the left, you can actually say the inside is one term. They have exponents of 1, 1. You can distribute the 0 to both of those. So really that's 2 to the 0 times x to the 0. And like earlier, a number to the 0 is 1. A letter to the 0 is 1. 1 times 1 is 1. And this last one, be careful. There's no parentheses. The 0 is touching the x only, not the 2. The 2 has its own power of 1. So really this is 2 times 1, which is 2. So a lot of kids get the last 2 wrong. If there's no parentheses, the exponent's only next to the thing it's touching. Applies to the thing it's touching. All right, now we can get to the adding, subtracting. So when you're adding or subtracting polynomials, you just determine if the parentheses matters. Parentheses only matter if there's an exponent outside the parentheses, or if there's a number or negative sign in front of a parentheses, which we have to distribute. So this first one, we have parentheses plus parentheses. So this is an adding problem. All we do is check does parentheses matter. The first one does not have an exponent right here, so that's good. It also does not have a number or sign in front of that, so that's good. So technically the parentheses don't matter. But you can put a 1 there if you want and distribute a 1. But you do 1 times anything, it doesn't change. Just say negative 5x squared, positive 4x, negative 3. The second parentheses does matter. I have to distribute this positive 2 to all these. That gives me a positive 2x squared, positive 10x, and positive 14. And all you do now is combine like terms. When you combine, remember exponents do not change, only when you multiply or divide. So here's x squared, here's x squared, and we're not going to the other side of the equation sign, so they do not change the signs, just combine them. Negative 5 and positive 2 combine to negative 3. With the x squared, we have positive 4x, positive 10x. Well, 4 and 10 together make 14. With that x, then here's the constant term, the non-x, and here's the non-x. Negative 3 plus 14 is 11. There's my answer. So once you go to the parentheses, you just combine. It also states the degree. The highest degree comes from that 3x squared term. The degree is 2. Again, this has a degree of 2. This has a degree of 1. This degree is 0. The highest one is 2. All right, down here, same idea. I'm going to check does the parentheses matter. The first one does not because there's no exponent or number or sign in front of the parentheses. So the inside stays exactly the same. No change. The second one, it does matter. I have to shoot this negative 3 to both of these. So that gives me a negative 3x squared minus 6x minus 15. I combine like terms again. X squared. Negative 1 minus 3 is negative 4x squared. Negative 3x minus 6x makes negative 9x. Then the non-x, 4 minus 15 is negative 11. Alright, and the degree of this is also 2. Alright, so that's adding, subtracting, pretty straightforward. Can you distribute and combine? The special one is, and the real one is multiplying. When multiplying parentheses, we will distribute every term in the first parentheses to every term in the second parentheses. We have an acronym if it's 2 things in each parentheses, and that's called FOIL. That tells us what order to multiply. F stands for the first terms, O is the outside terms, I is the inside terms, L is the last terms. And it's short to double distribute. So going to this problem, this was 3n plus 4n squared. Now I cannot distribute that squared power because it is 2 terms on the inside. I can only distribute exponents to other exponents if it's 1 term on the inside. So I have to do this the long way. I have to just write it out. When you square something, it just means times itself. So that's why this problem is a parentheses times parentheses. So now we're going to FOIL. We're going to do the first numbers. So 3m times 3m, that gives me 9m squared. Then the outside numbers, the leftmost and the rightmost. So 3m times 4n, that's positive 12mn. But basically, I just distribute the 3m to both things on the right side. At the other side, the 4n, or the inside really, 4n times 3m is also 12mn. Then the last terms, the 4n times the positive 4n makes positive 16n squared. There should be 4 terms when you FOIL. 2 things times 2 things gets you 4 things. You combine, and then you're done. There's no other m squared, so it stays 9m squared. But here is mn, here's mn. 12 plus 12 is 24. It stays mn because we're not changing, or not multiplying. Don't change the exponents. Then here's the other thing, the n squared. That's the answer there. It says, what is the degree? The degree of each term is 2, because the first term has m squared, that's 2. The last term is n squared, that's 2. And the middle has 2 letters, mn. They both have exponents 1, so 1 plus 1 is 2. So 2 is the highest. Alright, then we have this last one. Here we can't FOIL because it's not 2 things in each parentheses, it's 3 things. But it's just distribute, so here I'll say triple distribute. Basically everything in the first parentheses multiplies everything in the second parentheses. So we're going to get 9 things here. We're going to multiply this negative x squared times all 3 of these. So it's 1, 2, 3. And that gives me negative x to the 4th power. Because negative 1 times 1 is negative 1. Then x squared times x squared is x to the 4th. The exponent rules. Negative x squared times 2x is negative 2x cubed. Then negative x squared times 5 is negative 5x squared. Alright, then I'm doing the next 3. So the negative 3x multiply all 3 of these as well. So that gives me negative 3x squared minus 6x minus 6x. Negative 3x cubed, negative 6x squared, then negative 15x. And the last one, positive 4 multiply all 3 of these. So that's positive 4x squared plus 8x plus 20. So it's 9 things. 3 things by 3 things gives you 9 things. Combine like terms and you're done. Here's only x to the 4th, so it stays x to the 4th. Here's x cubed, here's x cubed. Negative 2 minus 3 is negative 5. Then here's x squared, here's another x squared. Negative 5 minus 6 is negative 11. Negative 11 plus 4 is negative 7. Then here's the x term, Negative 15 plus 8 is negative 7 with x. Then here's the constant, nothing else to combine it with, is 20. So there's my answer. I state the degree, the highest exponent c is 4, so that's the degree. And that's it. Hope you enjoyed the video. Make sure you ask any questions in class. See you soon. Bye.